All right, so what I put together, it probably is going to be a little too basic for some of you, but just as a real quick to go run through, and we'll use whatever time we have left over with solving. But so rewriting each equation, so you're going to take your base, go grab your exponent, and come out with your output. And hopefully that made enough sense when I did 100 of them in your notes today. So take your base, raise it to your exponent, equals your output. Is changing it from, and I guess I should make that look more like a Y.
Yeah, are you sharing a screen with us? Because we just see the decimal screen.
Oh, good call. Thanks.
Miss Sigmund?
Yes, ma'am.
I sent the pinned book link in the chat.
Cool. So Robert and Randall, there's your ACT one if you want to start looking at it before I get it printed.
Thank you.
Yeah. Oh, Hala, she did it. All on Hala.
Thank you.
No problem.
Oh,
Appreciate Hala.
Okay. Now you should be able to see it. Sorry. All right, perfect. So again, grab the base, come out, pick up your exponent, and then come out with your output. So the base is always, so an exponential function, it's ax equals b, I think is the letters they usually use. A is your base, x is your exponent, and b is always your output. Again, as I say it, like the basement sounds really not mathy and definitely not math 3 level communication, but in my mind it makes sense because the basement stays in the base. So take your base, grab your exponent, and come out with your output. So 6 to the third power equals 216 is an exponential form versus logarithmic form. Now, theoretically, like number 2, you're never really going to have to switch those around other than if I'm just quizzing you on can you switch them around, like putting them in the other form. The reason you're going to want to be able to switch them around is there will be like a variable with the log. If you have a variable on your log side, then you are going to do better to put it in exponential form. And in exponential form, if your variable is up in the exponent spot, then you're going to be able to solve it in a logarithmic form more easily. So that's why this sort of exists. If you can remember in Math 1 doing growth and decay word problems, and if you got a teacher like me, you had a worksheet full of them, and they were working, and then one of them said, how long did it take for it to get to a certain time? And then you would put your function in your y equals and then go look in your table. This log form is how you would solve for time, because again, that's where your variable would be in your exponential equation. So you would switch it to log form and solve it using this, just so you have some sort of idea of why we're doing these. So then opposites. So this is our exponential form. Also that log, the swoop, it puts it as a lowercase e. And then so that's switching to logarithmic form. This is a little bit of a push, but still we're going to push him into the basement, get our next number, and our output is going to be our exponent. So it's going to be log base 14 of 1 equals 0. And hopefully you remember that when you raise anything to the power of none, it gives you 1. That's a little saying one of the students told me. Raise to the power of none gives you 1. So 14 to the 0 power is 1. So this is saying 14 to the 0 power is going to equal 1. So again, switching it back and forth. Log, shove it into the basement, 6. Go pick up your exponent, equals 1. Now, cool part for you guys, because this is a virtual class, but I will tell you, be really careful. As far as if you had to write it on a quiz, there needs to be, like on a piece of notebook paper, if this is your line, the 6 that's in the base needs to be below it. So if you write log 6 equals 1, there's not a teacher on the planet that's going to count it correct. So make sure you're kind of careful that your basement number or the base in the exponential form goes below, like it's a subscript to the original like sentence line. Hopefully that makes sense. So that's it as far as switching them back and forth. That will be on your quiz. So there will be a couple of those that hopefully you have in the pocket as some win points. Evaluate your expression. Again, just as simple as putting it in Desmos like we did earlier or in your calculator. And you can do it. So change of base again, just so we have exposure. You're going to take log of whatever your output is over log base 10 of 7, because again, if there's nothing in the basement, then that is going to be a log, assume 10. And so talking about TI, I already pulled it up, I'll go do it again. So math, if you go all the way down, log base, so I can put a 7, 343, and the answer is 3.
Miss Figment,
Yes, ma'am.
so if we were to type it in like Canvas or something, could we just put log and then the base, not the base number, yeah, the base number, and then the one that goes next to it in parentheses? Could we do that?
No. Let's don't do it like that. Just because it'll make it a habit that we don't want to form. Does that make sense? Because I see what you're saying, but ideally you shouldn't have to. I'm trying to make sure I'm not telling you a story. You shouldn't have to put it in at all. But more just to call out, making sure you understand that it is a subscript. But you shouldn't have to write it out for anything that I can think of right off the top of my head. And then for Delta Math, it gives you a subscript option. Like it'll give you the sort of like the change of base outline in Delta. But if you run into an issue, as always, just hit me up and we'll figure it out.
Sounds great, thank you.
Yes, ma'am. So what this says, log base 7 of 343, is that if I raise 7 to the third power, it is going to be 343. And that's why that switching between exponential and logarithmic form, so you're flipping numbers around. And like I said, these are really basic. They all have numbers. There's no variables and you're not solving, so it's not a huge deal. But so you understand why we're doing the easy part first. So in change of base, again, you can use it that way. And that means my log button, which is underneath x squared, so further down this first column, I don't want to lose my screen, but I can do log 216, close it, divided by log 6, and get 3. Or, as long as you have it, log base 6 of 216 should give you 3. So that's just to show you and prove to you it's the same thing. Again, the fractional one is your change of base. And I'm saying that so when you hear another teacher say it, you know you've heard of it and seen it. But both of them are accurate ways to evaluate these logs. All right, so solving equations. So these guys that have log base 10 for both of them. Oh, that's a bummer. My pen just completely kicked the bucket. If the bases match and they're on either side, now, either side, not on one side. There's one log base 10 and one log base 10 on both sides. These can be crossed out. You can completely disregard them and then just get to solving the equation as if it was an 8th grade math or math 1 equation. So like in this case, we're going to hold on to that x. We're going to move the 5 by subtracting. Negative x equals 9. Can't leave x negative. Don't forget about that negative 1. So we're going to divide by negative 1. And in this case, x is going to equal to 9. Negative 9. Same for number 8. But again, I'm going to say it real loud and proud because we are going to run into this later. Definitely you'll run into it in math 4. I'm lying, actually. You're not going to run it into math 3. It is math 4. The properties of logarithms means you will solve them and there'll be lots of logs on one side of the equal marks. So this only works when there's one log on the right and one log on the left. So log 19 can go away altogether and you are going to solve 5 equals 2n minus 8. So again, back to that just pretty basic equation. We need 2n by itself. So we're going to add 8 to both sides. Gives me 13. 2n. 2n is 2 times n. So to fix that, we're going to divide by 2 to get that by itself. And n should equal, depending on where you see it, 13 over 2 or 6.5. Both of those answers are valid. It just depends on the formatting. Now, those are both linear. This will happen to you. So considering in my mind the double logs like that match, it gets pretty easy because they're both on either side. I now have v squared minus 8v equals 40 minus 2v. Now, as soon as you see v squared, in your mind, it should click, oh crap, there's a quadratic. And maybe not the oh crap part. That's just me. But, so it's not going to be super 8th grade-y. It's going to definitely be math 1, 2, math 3 kind of problem. So we want to get everything, as soon as you see a v squared, everything on one side. V squared, ideally you would like it to stay positive with that positive 1 in the front because that's going to make it easier to factor. When you start switching things around, you'll have to factor out GCFs and all kind of wild stuff. So the goal is for your ax squared, so x squared, to have a 1 in the front and be positive. So I'm going to move move the 2v this way. So I'm going to add 2v, negative 6v equals 40. And we're going to subtract 40 from both sides, because we're trying to get it equal to 0 to get that quadratic in standard form. And then now we can factor it to be able to solve it. So I'm going to show you my favorite way to factor trinomials. So their a times c is going to go at the top. B goes at the bottom, so that's at negative 6. This one, a is 1, but I use this for all the forms. Some people argue it's not super mathematically sound, but if you learn this process, it will work for every single time you have to factor, if it is factorable, no matter what the value of a is. And so then I'm going to find my factors of 40 that will add or subtract to give me 6. So obviously 1 and 40, 2 and 20, 4 and 10, 5 and 8, and then we're done. So 1 and 40 will add or subtract to either give me 41 or 39. 2 and 20 is 22 or 18, depending if I add or subtract. 4 and 10 will give me 14 or 6. So that looks good, but you want to make sure you always check, because sometimes there's doubles that matter as far as your positive negative. 5 and 8 will not give me 6, so we are good with our 10 and 4. So 10 and 4. My b value is negative, so I know the largest one is going to be negative, so that 10 has to be negative. If this had not been a 1, you would treat this as if it's a fraction. Hear me out. It is not a fraction, but you are going to cheat the system and see if you can reduce. 1 over 10 you can't reduce, and 1 over 4 you can't reduce. So these guys are just going to fall over. It's going to be v minus 10, v plus 4. And that came from right there, and that came from right there. Then you're going to set them equal to 0 to solve. So v minus 10 equals 0, v plus 4 equals 0. So v equals 10, and v equals negative 4. So v equals 10, and v equals negative 4. So both of those are our answers for number 9. And so that's a meaty, throw in that quadratics in the middle of a different kind of function problem. If you know you need more practice on factoring, obviously just holler and let me know, and I will try to shoot you some extra stuff if you have some time and want to work on that skill. Factoring is a big stinking deal. If we are not good at factoring, we definitely need to work on that. And the sooner you work on it, because we're going to get to a whole different unit that's rational equations. And if you don't factor, you can't do the math 3 level rational equations at all. So we want to nip that as soon as possible, just as a call out. All right, so then that's it as far as the easy ones with log, matching logs on either side of the equal marks. The idea is that you need log base. So this would be like when we were converting them and moving them. So log, you want only these 3 parts. You need them by themselves on one side of the equal marks. So in this case, I have that negative 7, which is a problem. That negative 7 is attached by multiplication, so we are going to undo it by dividing by negative 7. And in this case, it doesn't make any difference. So log 12 4r now equals 0 divided by negative 7 is 0, because 0 is on top. And now you see your variable is attached to log, so your log buttons on your calculator are not going to help you. So this is where you're going to convert it to an exponential. So 12 raised to the 0 equals 4r is how you're going to rewrite it. So 12 raised to the 0 power equals 4r. And 12 to the 0 power, anything to the 0 power is 1. So that's going to be 1 equals 4r. We need r by itself, so we're going to divide by 4 on both sides. And r is 1/4 or 0.25, depending on the formatting of the question and the way they want their answers. Any questions about those couple?
Not on 10. 9, like you said about the factoring, I'm exactly good with that.
Okay. Well, I will, don't sweat it majorly right now, like super sweat, but know that we need to desperately iron out that skill. So just have it in the forefront of your brain that we need to work on factoring, and I will do what I can to help whenever I can. And obviously always reach out like you guys already do. So we're good. So number 11 is exactly like number 10. The numbers are just different. Same problems, quote unquote. So log base 4 of 5v is what we need to get by itself with nothing around it. That negative 8 is attached by multiplication. So we're going to divide by negative 8 on both sides, which gives us log base 4 of 5v equals positive 2. Again, your v is over there with the log, on the side with the log, so that means we have to convert it because we can't just type it in our calculator and keep boogieing. So we're going to take our base, raise it to our exponent, and come out with our output to put it in exponential form. So 4 squared equals 5v. And 4 squared, remember, is 4 times 4. So 16 equals 5v. We're going to divide both sides by 5 to get v by itself. And so our answer is going to be 16 divided by 5. Or if, like I said, depending on the formatting, you could have it as a decimal, which would be 3 point, whatever 1/5 is, as a decimal. Number 12, exactly the same again. So I'm going to skip that one just to get us some different looking ones. Number 12 is just like number 10 and number 11. So the guy on the outside, your 5, divide, and then work through like we did the last two. Now, this one is amazing. If you have one to highlight or you want to make sure you get down in your notes, this bad boy. Not because it's hard, just because if you don't see it enough, you will get overwhelmed because there's a boatload of things going on right here. Now that r minus 8 is all in parentheses, so that is your log base and then your output by itself. That whole parentheses can move together, that binomial. So the only issue we have on that side right now is that negative 8. It is not attached by multiplication, though. It has a plus sign. So we're going to have to undo that negative 8 by adding 8 to both sides. And you added because it was negative, because we need this side for these to zero out. And so we have log base 3 r minus 8 equals negative 4 plus 8 is going to give me a positive 4. And again, your variable is over there on the log side, so we're going to switch it to exponential form. So take our base, raise to an exponent, come out with our output. In this case, our output just looks a little messier. So 3 to the 4th power equals r minus 8. So 3 to the 4th power is 3 times 3 times 3 times 3, which is going to give me 81. Again, super basic equation at this point. Get r by itself. We're going to add 8 to each side. Just coincidental that it's 8 again, that we're using 8 again, not a thing to note. And so 89 equals r would be your answer for that one. Again, as long as you're going slow enough and you realize that log, base, and then something. If this happens to be log base r minus 8, but r minus 8 is not in parentheses, then that minus 8 would be just like this minus 8. The parentheses is the only thing that will hold things together by addition or subtraction to hang tight as your output. If it's on the outside or there are no parentheses, then you need to get rid of it. Okay. Exponential. So switching to exponential here. So this is kind of like log base that matched on either side. Because the two bases match, you can pretty much ignore them. And you're just going to solve your exponents at this point. So 2x equals negative x. We are going to move everything to one side because we want it to be x equals, and these are like terms. So I'm going to add 1x because I like numbers to be positive. Equals to 0 because you just clean that side off, just like we did with the quadratic one. We need to get the 3 off the x, so we're going to divide by 3. In this case, x equals 0. Not always going to be 0, just how this one worked out. So, number 15. Again, the bases match, so we can get rid of these. And it's going to be negative 2n equals 2. 2n and 2 are not like terms. They're different. So we need to get n by itself. So we're going to divide both sides by 2. By that negative 2. Negative 2, negative 2. So n equals positive and a negative. Give me a negative. And that's it for that guy. Honestly, I've not seen a lot in that formatting in the testing and the websites and all the things that I've tried to do because there's not a lot of Math 3 EOC level questions out there still yet. They're getting more, but there's not many of those. So if you're trying to pick and choose what you're going to hold on to in your brain, just know it's easy and then push it to the back. So looking at 16. So again, in this case, our variable is not in a good place. You can't solve it when it's sitting up in the exponential spot. So you're going to convert this to logarithmic form. So you're going to push it down, grab, and then rewrite. So log base 4 of 1 equals 3r minus 1. Log base 4 of 1, we can type in our calculator and get an answer, or in Desmos, whichever way you're doing it. And you can do it by change of base again, or you can do it by your log base option. So log base 4 of 1 equals 0. So 0 equals 3r minus 1. Get 3r by itself. So I'm going to add 1 to both sides. And so 1 equals 3r. Get rid of the 3 by dividing. R equals 1/3. So that is the switching of it. I'm going to stop for the moment because that's our 30 minutes and see where you're at.